All right. So, welcome back, everybody. Hope you guys are doing well. Happy Friday, and short week, especially because you guys only came to school 2 days this week. But yesterday we did a little bit of remediation on cert and mission assignment, things like that. Some of you I talked to about grades a little bit. If you have noticed, or if you got my remind text last night, Integrated Science A is back open for you. And I would highly encourage everybody to just double check your grade for Integrated Science A. Whether it's on Canvas or Infinite Campus, wherever, are you happy with your grades? Average them together, quarter one, quarter two, add them, divide by 2, that's going to be your grade for Integrated A. If you're happy with it, well, you don't really have to do anything. If you're not happy with it, you need to get stuff turned into me as soon as possible, preferably by next Wednesday. I tried to warn you guys that Integrated A is going to go away. I did not know it was going to go away yesterday, but it did. We got it back open for you. You guys have about 5 or 6 days, about 5 really. If there's anything you need to do for Integrated Science A, get it done. Get it done this weekend, whatever. Again, I understand you might be behind or failing other classes, but Integrated A is going to disappear. You will not be able to fix it after next week. You can fix all the other classes after next week, but Integrated A is going to be gone. It's going to lock you out. So if you want to fix anything, and again, I talked to some of you already about it, if you want to fix anything, do it over the weekend as soon as you possibly can. Okay? It is available now. And again, it will go away next Friday, I think. It's going to go away again. For this course, we are now in Integrated B. And again, we all should have an A+ right now. Let's keep it at A+ all quarter 3, all quarter 4, and we won't have anything to worry about. Okay? That should just be our simple goal. So every day, like we've been doing, some notes, time for an activity, just get the work done during that time. Okay? All right. You guys hopefully see the notes above me. You guys obviously see them on the board. So for about the first 10, 15, 20 minutes, we're going to do lecture style. You guys are here for questions, obviously. I am going, you guys can just type in the box and give me whatever question you guys have. Anytime we do notes or lecturing or whatever, I highly encourage you to have paper or pencil to follow along and take some notes, okay? I'm going to say more than what is on the slide, and I would encourage you to make your own set of notes, things that you think is important, things that Mr. Can said. If you are in person here in front of me, I'm going to ask that you guys are paying attention to me. Yes, you can follow along with the notes on your laptop, but I don't want you staring at your laptop the whole time, okay? I'm going to be presenting the notes, so I want you to pay attention to me. When I switch the slides, you can switch the slides, and then look back up here at me. Okay? Too often kids are staring at their laptops, they're not paying attention, they're doing other work, they're doing other stuff. That's not what this time is for. This time is for learning. Then we'll get on the laptops and do our work. Okay? So again, use your time wisely with that. Okay? Make sure that you are paying attention to the notes. Make sure you are doing science stuff during this time. All right, we're gonna go ahead and get started. Again, if you guys do have questions, just put them in the chat box. I'll hear the little alert notification. And then obviously, if you guys have questions, just raise your hand. So on Wednesday, and I'm gonna stand up too. I like standing when I talk. So on Wednesday, we were talking about. We talked about the new unit of space science, and we're actually going to go way back in time to the very beginning of space science and how the universe itself was started. And so we talked about the current theory by George Lamarck, and called the Big Bang Theory. It's been around for about 100 years. It is supported with evidence. It is supported by scientists. It has gone through the rigor and the test and arguments and debates for the last 100 years. It's still the current top theory for how the universe started. Okay. There is some evidence that we're going to discuss today, and then we'll dive deeper into that evidence next week. So today is just going to be a brief hit on why scientists think the Big Bang is what happened. Okay. You guys have data or notes that are coming your way there. So in the 1920s, telescope technology finally started getting good enough where we could start observing the universe itself. Believe it or not, before 1920, we didn't even know there were any galaxies besides our own. That's all we could see. All we could see is our galaxy, stars that are in our sky. With the advancement of telescopes, we were able to see other galaxies that are out there, and then we're able to notice that there are a lot of other galaxies out there. Okay? So just as many stars you see in the night sky, there are galaxies out there. And so with the telescope technology, we're able to see more and more galaxies. And then we're also able to see that things are happening in the universe. It was actually, there's a lot of history with the Big Bang, like how people figured out what they figured out. There's a lot of cool stories. They made some videos, movies about it. But it's actually pretty interesting of how quickly scientists got the data and how quickly they came up with the idea of the Big Bang. To be honest, the reason why it happened so quickly is because the data is pretty common sense. In a scientific world, the Big Bang Theory is not controversial because it's so obvious what's going on. Okay? Do we know everything about it? Absolutely not. We're still learning, we're still working on figuring out things we don't know about the Big Bang. But given the data that given the data that you can go see with a really high powerful telescope, given that data, you'll come to the same conclusion pretty easily. Okay? And so there are three main pieces of evidence that we're going to focus on for the next 2 weeks. And we're going to hit them today, and then we're going to dive deeper next week. As we start these notes, if you made a copy of the notes on Wednesday, you might want to make another copy because they've been updated, and next week's notes are on there now as well. The notes are pretty much finished for this week and next week. So if you remember, I told you the next week's lesson coming soon. Well, they're up there, they're on there. Okay? Your weekly schedule for next week is also already on your Canvas. So, the three main pieces of evidence for the Big Bang, and again, so there are three of them. Number one, and we'll talk about all three of these today. Number one, and the most obvious. Sorry, I got something myself. The universe is currently expanding. And we can see it. We can measure it. It's happening. It's been happening for 100 years since we've been collecting that data. Since we could start seeing it, it's still happening. The universe is expanding. Things are moving out there. Okay? So that's the first piece of evidence the scientists got. Okay, and we'll talk about what that means in a second. That's a pretty obvious one. The second piece of information is that the universe has what we call background radiation, background energy everywhere. Okay? So there is energy, there is radiation everywhere in the universe, even where galaxies don't exist. There is energy still there. So the question is, where does that energy come from? Okay? And so that's another piece of information. And then the last piece of really obvious data is the composition of the universe itself, the elements, the atoms that make up the universe. Okay? Comparing what we see today and what we know about how elements are made, we can figure out what the universe started with. We can also figure out how much time it took to make the elements, and how long it took, and how much longer we have as a universe. Basically, a composition of the universe basically says that there is a certain amount of material, and we will eventually run out of material in the universe as we create more stuff. And then, so the universe is not infinite. You know, it had a starting point with starting ingredients, and now the ingredients have changed today. Okay? So we're going to talk more about that in a little bit. So those are the three main pieces of evidence. And again, we're going to go deeper into all three here in a second. So if I go too fast, you'll see me again. So the first one is universe is expanding. Okay. This guy right here is the one who observed it, named Edwin Hubble. We named the Hubble telescope after him. So as I said, technology for a telescope got a lot better in 1920. Edwin Hubble is the one who said, hey, the galaxies are moving out there. I can see them. We can measure them. Now, he had to convince people that there were more galaxies than there are. That was the first problem. But again, it's pretty obvious when you look at the picture. Like, yeah, that's not a star. That's a whole galaxy of stars. Right? That was the first problem he had. He had to prove that there were other galaxies. But then when people realized, when people learned there were other galaxies, then he said, not only that, but they're moving again, and so he was able to collect that data as well. So George Lamarck used Hubble data to kind of bring out the idea of the Big Bang Theory. The Hubble was first, but George Lamarck kind of put it all together. Okay? And relatively quickly, but all within a few years. So Edwin Hubble, he noticed that galaxies were moving away from each other. Not necessarily the stars that are in the universe, but the galaxies. They're all moving away. Okay? And they're all moving away in expansion. We'll talk a lot more about how exactly he saw this happening. It's not really something you see with your naked eyes looking at the sky. You have to take in a little more data, but we'll talk about how he noticed that next week. That's kind of interesting. So, there are a couple of questions that Hubble information brought up to scientists, and you could probably answer it with common sense right now. One of the first questions was, why is the universe moving away? Why are galaxies moving away from each other? Shouldn't gravity be bringing them together? And it should, right? So what's the opposite moving away is coming together, or they're not going to move at all. Okay? We talked about Newton's laws of motion. Okay? If you throw an object in motion, will stay in motion. Well, the universe, the galaxies are moving. And they're going to continue to move until something stops them. Until they hit the edge of the universe. I don't know, maybe there is a balloon around us. And the balloon pops, who knows? Right? We don't know. But the universe, the galaxies are going to keep moving until something stops them from moving. There is something that can stop them, gravity. Gravity can stop them from moving. The question is, why is gravity not stopping them? Why is gravity not bringing them together? And that's because they're moving faster than gravity works. So the second law of motion, if you want to accelerate something, make it move, you have to apply the force to that object. And so the universe is an object. If you're going to make the universe expand, what caused it to expand? What forced the universe to move away? Well, we think it's the Big Bang. Big Bang caused the universe to move away. Okay? And it will keep moving until something stops it from moving, even 14 billion years later. Okay? So if they're moving away, what force event? The Big Bang. If the universe is expanding, what would happen if we hit the rewind button? if we hit the rewind button, how long would it take for everything to come back together? Okay? These are really simple observations. These are really simple questions that scientists had when Hubble said things are moving away from each other. Well, why? What caused that to happen? Why isn't gravity bringing them together? They're moving faster than gravity. Okay, what caused them to move faster than gravity? We don't know. A couple years later, maybe there was a big bang, big expansion. Okay? Well, what happens if we hit the rewind button? Everything comes back together. How long did it take? So these are all questions that scientists were able to figure out relatively quickly. Again, we can measure the expansion. We can measure how fast they're moving away. And therefore, we can do the math and figure out how long does it take to bring it all back together. Not only that, scientists also kind of know where it happened. There's kind of a center of the universe, and we're not really close to it. There are videos you can watch about where we're located in the universe. We're kind of out there in the universe, but scientists can kind of figure out where it happened. Okay? But again, you got to remember, there was no outer space when it happened. Outer space was inside that singularity. There was nothing. There was nothing before it happened. It's weird. All right, so that's piece of evidence number one. Super obvious piece of evidence. It's really hard to argue with this, that the universe is expanding. Maybe it'll stop expanding tomorrow, and we'll collect different observations and different data, but that's not what's been happening for the last 100 years. Okay? So this is what we have. All right, the second piece of information, evidence, is cosmic microwave background radiation, what we call CMBR. Okay? This is the radiation that is everywhere in the universe. So, according to the Big Bang, get the note down. According to the Big Bang, at the very beginning, the entire universe was in an atom, the size of an atom. It was hot and it was dense, and it was filled with energy. It was hot, temperature, energy. Well, if you expand something in 3 dimensions, that temperature and that energy is going to go in every direction. Do you agree with that? Okay. So, I mean, a really simple analogy would be if I painted a balloon that was uninflated. If I painted a balloon with blue paint and I blew it up, the blue paint is going to go everywhere on the balloon, right? The blue paint is going to cover the balloon in all directions. Well, same thing happened here. There's energy, there's radiation, there's temperature everywhere in the universe. And even where galaxies are not there, even where there are no stars, there's energy, and even in empty spaces. Right? So scientists Penzias and Wilson, those are 2 guys, you might want to know their names. They were using this horn antenna telescope. We'll talk more about that next week. But they were observing every corner of the sky, and they were collecting energy. Okay? And that energy is leftover energy. Well, scientists think that energy is leftover energy from the Big Bang. Okay? Again, we haven't proven that, and we probably never will. Okay? So, cosmic microwave background radiation fills the entire universe, and again, that is something that we can collect. That is something that we can observe with the right technology. So, another question that scientists have. Why is this energy everywhere? Right? So, they collected data. They asked another question. Why is it everywhere? They also asked, where did the energy come from? Why is there energy where no stars are, where no galaxies are? That doesn't make sense. Okay? If it was just our galaxy, the energy would be here with us. Okay? Every galaxy would have its own little energy ball out there in the universe. But the energy is everywhere, even where the universe or galaxies don't exist. So again, the question is why and where did it come from? Well, they think it came from that initial Big Bang. That Big Bang had all the energy of the universe, and then it's brought it everywhere. And that's the reason why even the places that don't have places have energy, have radiation. Yep. So this is a really, again, really obvious piece of data that we have. Okay. And again, we've been collecting this data for about the last about 70 years. We've been collecting that data. And again, we're getting better and better and better with more and more technology. All right. So the last piece of evidence is the composition of the universe. So according to the Big Bang Theory, the universe started off as hydrogen and helium. Maybe a tiny bit of lithium or beryllium, but the universe started off with about 75% hydrogen. If you look on the periodic table, hydrogen is element number 1. It has 1 proton. Well, that's really easy to make. 1 proton. Okay, the electron loves it. So you get an electron and proton together, you got yourself hydrogen. So hydrogen is super easy to make. The Big Bang also made a little bit of helium. Helium is element number 2. Now that's harder to make because the protons don't want to be together. They're positive. Remember, 2 positives are going to repel each other. So helium is harder to make. And you need something like a star. You need a lot of energy to put 2 protons together. And so scientists theorize that the Big Bang, after it was, a couple 100,000 years later, hydrogen and helium were the two main elements that we started with. But here's the thing: stars are made of hydrogen, and stars make heavier elements. Stars make lithium and beryllium and carbon and oxygen and nickel and copper and gold and all those elements. Stars make those elements. Okay? And so scientists can look at the universe today and they can see how much carbon is out there, how much oxygen is out there, how much iron is out there, how much gold is out there. Okay? And scientists can predict or do the measurements, figure out that they can calculate how long did it take stars to make that much carbon? How long did it take stars to make that much gold? How long did it take stars to make that much blah, blah, blah? Okay? Knowing the ingredients that you start with, you can figure out how long it takes to make the final product that we have today. Okay? Now, stars are hydrogen. They will eventually run out of ingredients. They will eventually run out of fuel making these elements. They will expand and blow up eventually. Okay? When they blow up, gravity can bring all of that hydrogen back together and make a new baby star. Eventually, that star will run out of energy making elements, expand and blow up. Gravity brings all the hydrogen back together, makes a new baby star. That little star will make elements, run out of fuel, blow up. Okay, you just keep this process going. But as you can do the math, you start off with a big star, but then you're going to make a slightly smaller star because you ran out of fuel, right? Then you're going to make a slightly smaller star because you got less fuel. Make a smaller star, you have less hydrogen. Eventually, the universe is going to run out of hydrogen because it's making the bigger element. And eventually, there will be no more stars. Okay? Because the stars are making heavier elements. And when they run out of fuel, you're going to run out of fuel. You're not going to have any more stars. Luckily, we don't have to worry about that. The universe is still relatively young. But again, it goes to prove a point that the universe has an end date. It also has a start date based on the ingredients of the universe. Okay? And so the recipe, so to speak, the composition today is still mostly hydrogen. So we're good. We're in good shape. We're still going to have stars. The universe today is still mostly hydrogen, still quite a bit of helium, but then there's about 1% all the other elements. And so again, scientists can calculate how long did it take to make all the other elements. And it turned out that that number is very, very similar to the rate of expansion from evidence number 1. So evidence number 1, if you hit the rewind button, it takes about 14 billion years to come back together. If you look at the composition of the universe, how long did it take to make all that stuff? It took about 14 billion years. Okay? If scientists looked at the universe and they said, wait a minute, there's not that much hydrogen left. It would take hundreds of billions of years to make all those elements. Well, those two pieces of evidence wouldn't support each other. They wouldn't support the Big Bang. So you have three essentially smoking gun pieces of evidence for the Big Bang. And they really support each other without being the same piece of evidence. The expansion has nothing to do with the composition of the universe. But yet they still give you about the same number when it comes to the age of the universe. Okay. So those are the three main pieces of evidence that scientists have. There's more. Next week, we're going to dive into how Hubble knows that they're moving away. We're going to talk about how Penzias and Wilson, how they measure that radiation next week as we go from there. So there are some additional resources. I highly, especially if you're interested, if you like the information, you like the material, I highly encourage you to check out the additional resources. This is kind of one of those controversial topics that a lot of kids like. They want to know more about it. Feel free to ask me about it, but there are a lot of good stuff. There's hundreds of articles out there. I really like these, the ones I'm giving you. Right. So I encourage you to watch a couple of videos, read a couple of articles if you're interested. All right, today's assignment. We have about 15 minutes, about perfect. We're not going to do breakout group today. Today's assignment is kind of individual, but you are going to interact with your classmates in the assignment itself. So if you go to the weekly schedule, go to Canvas, you will see the assignment for today, Big Bang Theory Activity B, and then boy, and it is a discussion board. I'm going to ask you to answer the question yourself, and then I'm going to ask you to reply to 2 classmates. Okay? Now, your classmate replies need to be good. They need to be well developed. Okay? Don't just say things like, good job, way to go, I agree. Okay? Have a conversation with the person you're responding to. Use their name. Okay? Tell them why they're right. Tell them why they're wrong. Do a good job discussing science that you've learned. Okay? It's no fun when you guys are talking about science and you're like, yep, I agree. Yep, you're right. That's no fun. Okay? Just have a conversation. Talk about it. Okay? So on there, discussion board of questions asking you about using the evidence that we talked about. Explain what would happen if you did turn back the clock. What would happen with all that energy that's out there? What would happen to the non-expanding stuff? What would happen to the composition, the atoms, the elements, if you rewound the clock? What would happen to the universe? Okay. So use those pieces of information to explain the rewind button and what you would see if you were a scientist, if you were there. Again, it is a theory. That does not mean that it is wrong. We will probably never prove the Big Bang Theory until we invent a time machine and we go back there and watch what happened. And we recorded it and we collect the data. We're probably never really going to know what happened. Okay? The only other option for us to know what happened is to maybe a new universe start and we can watch it start. We can watch it and see what happened. It hasn't happened. I don't know what that would do to our universe if that did happen. But again, that's pretty much the only way we're going to prove what happened to our universe and how it started. But we do have data, we do have information to suggest that there was a starting point, and that there probably will be an ending point as well, right? Way down the road. All right, you guys have time to do your work, and my core one already did this. You guys can respond to them. So there are plenty of people that you can talk to. Talk to 2 people, two discussions, do a good job, and then that's it for today. Okay? If you finish today's, make sure activity A is done. Make sure your cert videos are done. I think all that stuff is due this week. If you don't finish the discussion board today, it is due on Sunday. But again, don't wait till Sunday, just do it right now. All right, that's it for me. I'm gonna be quiet. If you guys have questions, obviously ask. If you guys have questions, put them in the chat box. I'm also gonna stop recording, so that's about it for today's lesson. All right, that's it for Friday. Get your work done.